Go ahead. Hey, good afternoon. Welcome to the iCar SCRS Collision Refinish stage. I'm Scott Caboose with iCar, and I'm here with Dean Brennan from IPG Photonics and Evan Shea with Serra Laser. And guys, I'm going to let you get right into your presentation and show us what a great product that you've developed.
Well, great. We're introducing laser technology for welding automobiles. I'm going to do a short presentation on how lasers work and why it's good for automobiles. IPG is the company I work for. We're based in Oxford, Massachusetts, and the machines are made in Boston. And the big thing that we want to talk about is how we're going to use photons of light to weld instead of electrons. So, just start it here.
Let's go.
So our technology is actually a semiconductor product using emitter diodes that create laser light, and they're solid state lasers. So the reason why I have this diagram up is that it's different from how you weld like with a MIG or TIG welder. MIG or TIG, you're using electrons. You're creating an electrical arc to melt the metal. We're using light. There's no electricity running through the parts when you're welding. It's strictly photons of light energy. So that's really right there is the heart of what we make. And those little packages of light are combined, and how many you combined creates how much power you can use. So the product we're showing today in our booth just over there is 1,500 watts of laser power, which is going to equate to a 1/4 inch of material thickness penetration. That's for aluminum, stainless steel, or steel. So that's the unit there. It's an air-cooled unit. It's about 150 pounds. It's the size of a typical MIG or TIG machine. It has a power cord. It has a cord that delivers the light to the welding gun, and that cord is actually a fiber optic cable. So there's no mirrors that you're dealing with on the machine at all. It's all solid state, and it's very inexpensive to operate. It uses a 23 amp of power at 220 volts. So no water cooling at all.
So pretty much any shop in town is ready to plug this in and work.
Absolutely.
That's great.
And so the reason why this works for the automobile industry and just in general metal cutting or metal welding, I'm sorry, is this. If you look at this slide here, per square millimeter, an arc weld or a MIG weld or a TIG weld is going to be about 50 watts of power density in that area. With laser welding, the power density is 10,000 watts. So what that does, 10,000 watts versus 50 watts, the difference is heat. It's heat going into your part that's not doing work. So it's very, very efficient for being able to focus the light energy where you want to make your weld.
So instead of heating the panel and heating the wire and melting them together, we're able to heat the wire and just melt the wire and just exactly where we want that weld to go.
Yes, so you can program up to a 5 millimeter wide weld, and what it's doing at that time is the beam is actually oscillating back and forth and stirring the metal. So you're stirring the two parts you're trying to put together along with the wire that you're adding.
So what we end up with is a minimal heat effect zone, if any.
Well, you've used it.
I have, and I love it. And
I'm going to get you one.
Almost no warpage. I mean, we were making very long open butt welds on thin metal, and the panel wasn't moving at all. And if we had tried that with a MIG welder or a TIG welder, it'd have been a mess.
And also what happens is that you don't have a proud fillet. So you're not adding material to grind it off later. Mm-hmm. And we'll show some video here. You can see that there's not a lot of splatter or other things going on. in the process. So these are the bullet points. It's faster, there's less prep, shorter weld time, a higher quality, there's less heat input into the material except at the point that you're actually doing the welding. And the other thing probably that's very interested in this crowd is the fact that it's easy to learn. So what a TIG or MIG welder might have to work on for months or even a year to master, you can get somebody up and going with some practice in a day or two, and they'll be experts in a month. So it's pretty, there's a lot more to welding than just laying a bead down. But as far as laying the bead down, it's pretty fast to get up and going.
Yeah, I know when we were there, that was one of our big takeaways is the learning curve was very short.
Right.
If you had a little bit of background, a little bit of understanding, and then forgot your technique of how you MIG or TIG weld, you could pick this up and use it very quickly.
You have to have amnesia.
Yes, you have to forget what you know about welding because this is totally different, but it was very simple to understand and easy to get the hang of.
That's right. When you pull the trigger on this, you don't have to look for a weld pull. You can trust that there is a weld pull. It's time to get going.
Yeah. Yeah, it's much faster too.
Yes.
We were running long beads extremely fast. I've never welded that fast in my life. And when I got behind here, that was the hard part, is to learn, hey, I've got to move a lot faster than I do with a MIG welder.
Yeah, we actually have conditions that pulse the laser to slow it down. So, you know, there's a lot of different options, but it is fast. So there's different molds, there's different modes to laser welding. There's, you have a continuous wave or you have a pulse wave. And we have preset conditions inside the machine. So all you have to do is go to what thickness of penetration you want, and you just dial in the condition, and you're off and going. So we have 54 presets and then 20 user presets. Pretty much the standard presets work out of the box.
Yeah.
So here's a sample of a 1/4 inch weld. This is an autogenous weld. We're not adding any wire.
So we have the option of doing this type of weld with no wire at all, or having a wire feeder and choosing whatever wire we need based on our material.
That's right, and it's also quite a spot welder too.
Yeah.
So there's the tack. When he does the tack, that's actually a program. So the laser is ramping up and down in power, and the dwell time to actually make that tack weld is all programmable. So you just pull the trigger, you hold the trigger until the cycle is done.
This one appears to be aluminum as well.
That's right.
Yeah, and we got to play with a lot of different materials. We were mild steel, high strength steel, aluminum. We saw some copper,
Yes.
brass, pipe, a lot of different applications.
And in the collision repair, you probably want to use wire most of the time just because you wind up with gaps.
Yep.
So you're going to want to fill those gaps. And the other thing too is with the amount of plated or plated materials, the galvanized, there's techniques where you can use silicon bronze wire and you can weld at low enough power settings that you don't disturb the zinc when you weld those parts together.
Yeah, that was amazing. So we see a lot of vehicles today being built with robotic laser MIG brazing, where the roof's being put on with a laser MIG braze on a gutter seam, and we were able to almost exactly replicate that with this handheld.
Well, most likely you drove in on a car today with a roof that was welded with an IPG laser. We've been supplying to automotive builders for 20 years.
Yeah, at the manufacturer level.
Yes, at the manufacturer level. This is our first handheld product.
So you can see the arc there pulsing.
Yeah, so the modulation mode really helps control distortion and also helps you go a little bit slower to control welds going around curves and tricky applications that are not such a straight line.
Yeah. And your bead, it was amazingly narrow and amazingly flat.
Oh yeah.
So we had very minimal work to do when we were done welding to dress that and present it.
It's showing the spot welding there, just going through two pieces of metal, so it's able to replicate a spot weld from only one side of the material, so long as they're making good contact.
So in this case, the lower piece of metal is half the thickness of the one on the top, and we were able to control the penetration through both materials very precisely.
And for those of you that missed it, that's aluminum. They're doing spot welds on aluminum.
So this is an example of some of the different welds. It's strange that in a lot of cases the machine doesn't, the photons of light don't see what the metal is. So if you add wire, you can weld a lot of dissimilar metals together, and maybe sometimes there's little secret sauces in these shops repairing where that has to happen.
It may happen.
I was thinking that.
Yep.
So a byproduct of this is that we can turn down the power and actually oscillate the beam wider, and we can do a cleaning process.
So this would be great before we weld that roof panel on, run that down there, clean all the product out of there, make sure we've got any impurities out of the area first, then go back and do our MIG braze joint.
So that's right. You can do that, but also since it's laser, when you're welding with photons of light, you're really concerned. I mean, with electricity, you're really trying to get those electrons to flow evenly through all the metals. So that's why the cleaning is so important. And if you can live with the impurities in the weld and still have a strong weld, the photons of light, the laser doesn't see those impurities. So it's not going to see the oxidation on aluminum. On the galvanized, I would prefer to leave the zinc in place and just use a process where we're going at very, very low power and not disturbing the zinc.
Yeah. Yeah, then you've got the extra corrosion protection in the joint.
And exactly, yeah. But it's very common that people will weld, with stainless steel wire on all steels. So here's the case of we are taking off the galvanized.
So I find this part, cleaning the galvanizing off, especially helpful with lap joints where the galvanized becomes trapped between two pieces. So cleaning that off beforehand can really help with eliminating the off-gassing of the zinc and the popping of the weld.
Well, I also saw some video earlier of it removing seam sealer, right?
Oh.
So using the cleaning mode to actually clean seam sealer out of a joint.
Yeah, you definitely could. You want to use some fume extraction when burning off seam sealer or paint. In just a few minutes here, I'll show you the fender where I've removed the paint prior to welding. But yeah, you can definitely use the laser for that.
Awesome.
So just an overview, the laser, the PPE is a little bit different from typical welding. There are, you want to have an enclosed area or someplace where you can shield the light, or have the people in the general area wearing laser safety glasses. Some people use a booth. There are products out there that lend themselves very well for automotive manufacturing that are large movable curtains, and then of course you can have movable panels. But typically it's only the welder is the one welding with the light protection glasses. Now we always want to be cautious, but there's 1/10 of the UV light in laser welding. So you're not going to get a sunburn by welding all day. So you don't have the skin cancer risk that you do on some other products. We're not going to send electricity through the car.
Yep. But the safety portion is really important because the equipment is different, the environment's going to be different, and if somebody just walks in, they could damage their eyes not even knowing what they're doing.
So yes, so the way the machine is set up, it has interlocks set up in the machine so that you can set it up so if unauthorized people are coming into the shop, it just shuts the machine down.
Yep. I know the room that we were in had switches on the doors.
Yes.
So if somebody popped the door open, it just shut the machine right off.
Yeah, and the machine's pre-wired for that.
Yeah, yeah, and that was just a great way to ensure that, hey, we're not going to hurt somebody else that doesn't know what we're doing here.
That's right.
Yeah, with the minimal heat input into the parts, you know, I have a lot of TIG welding experience, and I found that I find that the TIG welding and MIG welding is actually more dangerous based on the fact that the parts get much hotter, so you're more likely to burn yourself just from contact. And as long as you're wearing the proper PPE with the laser welding process, it's actually very safe.
Yeah, but you've got to make sure you're doing that.
Yeah, of course.
But it is different.
Yep, absolutely.
So this is a new style of machine that we've come out with. It's a single mode laser. It's the same 1500 watts, and it increases the spot or the power density by 6 times. So this would be the model if you wanted to get into 1/4-inch steel, and if you wanted to do exotic materials like titanium, thicker coppers, 6000 series. 6000 series aluminum, like extruded aluminum, is reflective to laser light. This product has solved that problem.
Excellent.
And also to touch on the thin aluminums as well, the single mode units handle welding with the thin aluminum a lot better because of the reflectivity of that material. It allows you to turn the power down and get more control when you're working with thinner materials, essentially.
So how thin can we go?
I've welded very thin in the 25 thousandths range, and with stainless and steel, I've gone into the 5 thousandths range.
5,000.
That's the same machine that'll do a 1/4-inch penetration into that same material.
That's amazing.
So this is just showing our product line and what the capacities are. And that XR machine is the one that's a single mode. The other thing too is we did mention on there the process window. When you set a setting that works for a certain combination of thickness and materials, that'll repeat. If it's a special condition that you use, it'll repeat day to day, or it'll repeat. You did it today and you call it up again in a year. It'll be the same.
So if you're a fabricator or something like that, and you're dealing with common thicknesses of material or types of material, you can program your own settings in there to hit that sweet spot every time.
The same, yes.
Perfect.
Another thing on that point is that you're going to have less variance between the results from operator to operator. You touch the surface when you're welding with this, so the standoff distance is automatically consistent. So you're unlikely to have different results with the same settings with different people.
Yeah, that's what we noticed too. We had 5 or 6 of us there. We didn't have to touch the settings. We handed it off one to another, and we all made the same weld.
Oh yeah.
And if you did that with a MIG welder, that would not happen.
Nope, not at all.
So, so one of the huge benefits of welding with photonics is it doesn't care, is your electronics are not going to be affected by the welding process. So you do not need to isolate your batteries. You don't have to. It'd be great to repair a Tesla with this type of technology. It just is not sending off any type of electrical wave into the car.
So it may save a lot of time.
It could save a lot of time. And then the other thing too is that the aspect that you're welding, it welds the same upside down, vertically, flat. Because I'm guessing most automotive repairs are upside down or on the side.
It seems to be. And a lot of times we're doing a hat channel where we're doing, a flat surface, a vertical surface, and an inverted surface all in one weld. And this was able to go all the way around that hat channel with one setting, and the weld was the same upside down as it was flat.
Yeah, and with the oscillation of the beam, if you have to stop and restart a weld, you can just overlap that slightly, and a novice isn't even going to know that actually happened.
Right.
So are the welds strong? So this is a cross section of a 1/4-inch stainless steel. You can see on the right that the fillet is very, very, it's almost parallel. It's not the tornado-shaped weld that you get with the Tigger MIG. You would never like bevel a thicker part to weld this. You would just want to butt the parts together. And since you're focusing all that energy to the bottom, you can actually control where and what shape that weld's going to have. So this is an aluminum welding test without wire, just autogenous. And they're breaking it.
So notice how far away from the weld that panel broke. Almost every time we do that when we MIG mag or TIG weld something, it's going to break in the heat effect zone right next to the weld. This broke right in the middle of the panel. So that tells me the heat effect zone was so minimal that it didn't even affect metallurgically where that panel was going to come apart. That is very different than what we see with any other type of welding.
So Evan, can you show me the science project you brought along here?
Sure. Yeah, so knowing that we were coming to SEMA, we stopped by a few body shops and picked up some dented fenders to do some test welding on. Now, I'm not a body professional, although I have been welding for quite a while. And so we bought some flares off eBay to weld on here to simulate some thin sheet metal bodywork. So what this is an example of something that would take an incredible amount of time with a MIG welder, which is very fast and easy with the laser. This entire weld from that side to that side took less than 3 minutes. And the weld has not been finished afterwards. That is the appearance of the weld as it is created. I did 2 stops and starts in there just to reposition myself, but it took less than 3 minutes. The weld on the backside is actually a full penetration weld. It's something that can easily be controlled. If you did not want to get as much heat into the part, you could turn the power down and it would weld just as fine. And this panel has virtually no distortion after welding. It would take a very small amount of time to clean up and grind off that weld. It's almost to a point now where you could just lay a little bit of body filler over that seam and you wouldn't need to do any finish work at all. So yeah, I mean, it's an incredible tool for this type of process. It can also work for the aluminum. It's fully capable of working for a similar thickness aluminum. I know a lot of the newer cars are being welded with aluminum, and I wish I had an example of that to show you, but if you come by the booth at 38145 here at the SEMA show, we can show you some aluminum welding as well.
So you're able to weld right into the paint?
Oh, actually, I did clean off the paint. I used the same laser. This is the Lightweld 1500 XR that I was using, and I put it on its cleaning mode and did 2 passes over it to remove the paint and get down to nice clean sheet metal. You cannot catch your fingernail on that surface, so it did not disturb the base metal very much or introduce any distortion. I also did another weld down towards the bottom there where I attempted to weld it without removing the paint, and it did work. Had a little bit of issue with off-gassing of the paint, but you don't need to clean it as much as I did in this weld here to get a good result either.
So instead of taking a roll-lock grinder or something like that and removing the paint, you're using the laser.
Yep.
Which to me, almost any time you use a belt sander or a roll-lock or something, you're going to be removing a little bit of metal.
Yeah.
It's very hard to just remove the paint. Where here, you were able to do it with a laser, didn't affect the thickness of the metal at all.
Nope.
And yet it perfectly cleaned the panel, took the paint and any undercoats that were on there right off.
Yeah, and I believe the number when you are doing the laser cleaning, if you get the settings just right, I believe it's in the couple of micron range of what it'll get into the metal. So it's not disturbing the metal very much at all, nor is it adding much heat and distortion.
Yeah, no, that's a beautiful job. What filler wire was that?
I believe I was using stainless filler wire. This is a mild steel fender and should have used mild steel, but it works just as well with the stainless from what I can tell.
Excellent.
So Evan, tell me about your experience being a TIG welder and a MIG welder, about the differences as the user of this product and how this might help the collision industry.
Okay. Yeah, so I've been doing TIG welding and MIG welding, mostly TIG welding for over 10 years now. All just, some at work as a machinist and a lot of hobbyist stuff and building racing cars. So from what I've seen is that even after those 10 years, I still struggle to make perfect TIG welds every time. It's never going to be perfect, and obviously the more experience you have, the more perfect it will be. But what I see with the light weld is that I can bring people into our welding cell. I can give them a few minutes of training in some instances and have them making good weld beads right off the bat. Obviously, more practice is going to unlock the secrets that you'll need to be an expert with the system, but the learning curve is very shallow compared to any other welding process that I've done. And like I mentioned earlier, the results are going to be more consistent from operator to operator, so you'll have less variation in your parts, and yeah. Also, the welds are, from the testing that I've done, they're very strong. I know I hear some people questioning the durability of these welds, but they're way stronger than most other welds that I've seen.
Well, Starships and
I was just going to ask,
Yeah.
can you share some of your customers?
I don't think I'm allowed to.
Not by name?
But there's a little space company down in southern Texas that has 70 of these.
Yeah. Yeah,
So-
so there's major manufacturing companies using this
Oh yes, absolutely.
technology to build things that are very important
And
in the world.
they were already using lasers, so they're using automated laser systems that are $200,000, $400,000, $500,000. And in reality, all they need to do is have a human being with a good mind, knowing what they want to do to actually manipulate that beam. Evan, I do have a question for you. So I know there's some welders that are going to want to do this process, but they're going to go, hey, sometimes I get in these situations where I need to use a stick to get some filler in there, and all the tricks of the trade. Do those still apply? So if you have a welder that's like really knows what he's doing, can he actually do more with this?
Oh yeah. So the welders are advertised with, a certain range of capabilities, certain range of materials that they can handle, but you can definitely do a lot more than what it's advertised as doing. The settings that they give you on the chart when you have one of these systems are a really great starting point. 99% of applications, that's all you're going to ever need. But my job, I do a lot of testing for potential customers who are interested in this system. So I encounter a lot of applications that aren't listed on the chart, and it's, you have so much control over the system. You can make custom settings, and you can basically apply those settings into any situation. To touch on the part where you were asking about the TIG rod, if you can't quite reach the wire feeder nozzle into a certain area, you can lay down a piece of TIG rod onto the surface and just fuse right over it. If your gap is slightly bigger, you can use a bigger TIG rod to add more material to help fill slightly larger gaps. There's tons of tricks. I've used it for about 2.5 to 3 years now, and I'm still finding out new things, and it's a very powerful tool.
So what is the little motorbike that's over at the booth? What was the booth number again?
The booth number is 38145.
All right. And you have an exhaust system you put together last week?
Yeah, I had to make something to draw people in, right? So I have an old 70s Honda 90cc motorcycle, and I welded a stainless steel exhaust system from the flange to the tubes to the muffler, and it's bolted on there if you want to go check it out.
And you made the muffler?
Yeah, made the muffler, the baffle inside, and everything, all with the laser welder. Everything is either laser cut or laser welded in our shop with IPG laser cube and light weld.
So excellent, guys. I'm glad you came today. I know the collision industry, this is kind of a new product for us. I see lots of applications for it. Hopefully we can talk to some OEMs and get them to understand the value, the process, and the benefit of using something like this in the collision repair industry. I already know multiple fabricators that are using it and doing just amazing work. I don't know if you can talk about any of the people doing that.
Well, so there's several automotive manufacturers that in North America that are using the light weld to actually repair the automated remote welding systems that are there, especially in the roof assemblies. So I don't think your adoption is going to be very difficult.
It shouldn't be, because it's the way they built the car. To me, in my mind, if we repair the car the way it was built, it should react the same in the subsequent collision or any other environment.
Yeah, exactly.
So, well, great. It's been great having you guys here.
Thank you so much.
This time flew by really fast, and I'm going to head over to your booth and check out that little Honda.
All right.
See you there.
All right.
Thank you.
Take care, guys.
Bye.